In section 3.1, we're looking at the measures of center of a set of data. The first measure of center is the mean. And this is essentially what you would think about if you, say, needed to average regular test scores. So like if you had 4 test grades and each test was weighted the same, then you would just add them all together and then divide by 4. And that's what the mean is. You add up the data you have and then you divide by how many data points you have. The median is a little different, and we'll look at a couple of examples to do this. But to calculate the median, the first thing you need to do is order the data from smallest to largest. And then essentially what we want to do is identify the observation that falls in the middle. For a set of data with an odd number of data points, this is easy. For example, if we have a data set of size 3, if you order it from smallest to largest, then the middle value would be the second one. And similarly, if we had a data set with 5 data points, we order from smallest to largest, then the third observation, the one in the middle, if they're ordered from smallest to largest, then that would be the observation in the middle, the third observation. And there's a little formula that they refer to down there, which is n plus 1 over 2. So let's look at the example where n is 5, like I said. Then n plus 1 all over 2 would be 5 plus 1 over 2, which is 6 over 2, which is 3. And it really is the third data observation. Again, if the data is ordered from smallest to largest, that would give you the median. So if you have an odd number of observations, there's a clear middle value. If, however, you have an even number of observations, then what we have to do is take the middle 2 observations, and then we add those together and divide by 2. So, for example, if we had not 5, but say 6 observations, then the formula would give, so if n were 6, then n plus 1 over 2 would be 6 plus 1 over 2, which is 7 over 2, which is 3.5. So since we're getting that 3.5, that's telling us we're going to have to take the third observation and the fourth observation, again, ordered from smallest to largest, and we add those two together and divide by 2. The last measure of center we're going to look at is called the mode, and it's the easiest to calculate because it's just the observation that occurs the most. If there is no observation that occurs more than once, then we say that the data has no mode. So here we're given some data about the salaries of math consultants. I don't remember the exact context of this example, but we have 2 data sets, and these are weekly salaries. And so we want to calculate for each data set the various measures of center. Okay, let's focus on data set 1. We'll see if we can get those numbers. So to calculate the mean, the first thing we will need is the sum of all the data. So for data set 1, we first calculate the sum of the data, which is 6,290. And then seeing that we have 13 data points, we'll take that number and divide it by 13. The sample mean is typically denoted little x with a bar over the top, and the formula for that is 1 over n. So little n is the number of data points in the sample times the sum. And so that's 6,290 divided by 13, which gives, rounded to 2 decimal places, gives $483.85. So let's see, we have 300, and that occurs 1, 2, 3, 4, 5, 6 times. And then we have 400 twice, and so on. We'll just continue until we get all this data ordered. Okay, so there's all the data ordered from lowest to highest. And remember, we have 13 observations here. And so n plus 1 over 2 here would be 14 over 2, or 7. There's a clear middle observation, and it's the 7th observation. So 1, 2, 3, 4, 5, 6, 7 is the 400. And now remember, if we had an even number of observations, as is the case with data set 2, then there would be the 2 middle observations, and those two numbers would have to be added together and then divided by 2. And then the last value is the mode, and that's the one that occurs the most often, and that's clearly 300. Okay, here we see how the skewness of the data can affect the relationship between the median and the mean. So the mean is what we call more sensitive to outliers, and an outlier, we'll see that later on, but an outlier would be an observation that doesn't seem to fit as well with the other data in a sense. For example, if you think about the starting salary for a recent college graduate, well then, that may be somewhere around $50,000 to $60,000 a year or something like that. But then you also have, you have some people who get drafted into the NFL, or maybe somebody hit it big in the music industry or something like that, and they just happen to also be recent college graduates. Well, those people don't, they really don't represent the typical situation, right? I mean, not everybody's going to be making millions a year. And so when you have observations like that in the mix, the mean is more susceptible to be influenced by observations such as that, which is why when you look at the two distributions that are skewed, for example, part A is skewed to the right, the mean is more attracted to the direction of the skew. So like the outlier would be over here somewhere. Here's going to be your recent NFL draft person or whatever. These are the sort of, maybe not outliers, but these are sort of the more extreme observations. And again, the mean is more susceptible to outliers or extreme observations in the direction of the skew. And so that's why when you look at part C, the left skew, the mean is less than the median because it's being pulled, in a sense, more towards the left. And then for part B, with symmetric distributions, they agree. Okay, so here they're giving us the definition of the sample mean, which we looked at that earlier.